All right.
No.
Solving systems by elimination, also known as linear combination.
What? Yes.
No, we're not doing this right now.
Connor. Yes. No.
Okay, guys. So you have learned, this is the last method I'm going to teach you. You have learned solving by graphing, also known as inspection. I didn't say that before, but you see the word inspection on your EOC because whatever reason the state thinks inspection is a good word for graphing. I have no clue why. But that means solve by graphing. There's substitution, and then the next one you're going to learn is elimination, which is also known as linear combination because you're combining two linears together with addition. So you're eliminating a variable, sometimes why it's called elimination, or linear combination because you're combining two linears together. So that's where the two names come from. So here's how this works. You're going to combine the systems by combining like terms. So the first thing you need to know with elimination is that you need to look at your lineup and see that it's in a standard form-esque lineup. It's not exactly standard form because you don't have to follow all of those rules. But x and y are on the same side of the equation. So if x and y are on the same side of the equation and the x's are lined up and the y's are lined up, what you need to look for first is that the coefficient in front of the variable is the same on one of the variables, but opposite signs. So 3 and 2 are not the same number, so x does not have that. But in front of y, we have a 5 and a 5, same number, but one is negative and one is positive. If that is the case, you can combine the systems by combining like terms. That just means add the systems together. So all we're going to do here is put an addition sign here, a little line there, and we're going to add 3x plus 2x is negative 5y plus 5y is negative 16 plus 31 is
15.
So we have 5x equals 15. So once you've added them together, all you have to do is solve for the variable. In this case, we're solving for
X. Is that right?
Riley, how would you solve for x?
Divide 15 by 5. Miss Brady, that should be a negative.
No, it should not.
But you said I did it right.
Sorry. I looked at most of it. Because negative 16 plus 31 is positive. 31 is a bigger number. Sorry.
I'm a goose.
See the X's? No, go walk.
I can take a walk.
Hey, she'll get lost. I like your nails this bad.
Thanks, they're growing out. I need to get them redone. Guys, you need to stop talking. This lesson shouldn't take this long, but I'm just going to stop if you guys can't handle it. Do you understand me? So once you're done with that, you're going to plug back in, or substitute is another word, the variable back into one of the two equations. It doesn't matter which one you want to. And then you can find your solution, list your solution as an ordered pair. So, which equation, Emma, do you want to substitute back in for? 3x minus 5y or 2x plus 5y?
2x plus 5y.
So remember, when we're solving systems by graphing, or inspection is another name for it, you need to look for where the two lines intersect, which means you're looking for an ordered pair of where they intersect. That's why we need two different solutions, an x and a y, to create that ordered pair. So Grace, how would you write that up then? So, first problem. This is the easiest of elimination problems when it's already set up so that in front of one of the variables, the coefficient in front of one of the variables is the same number, opposite signs. But what happens if it's just the same number and not opposite signs, meaning it won't cancel out when you add it? So if you have a system that contains terms that would cancel out if they were opposite signs, multiply each of one of the equations by negative 1. So Tanari, which one do you want to multiply by negative 1? Okay, so I'm going to multiply every single term in the top equation by negative 1. You cannot just multiply the 2t by negative 1. We want this 2. We notice that 5 and 9 are not the same number, so those are not going to cancel out. But 2 and 2 are the same number. They're not opposite signs. So that's why we're multiplying by negative 1, because then it would be negative 2 and positive 2. The problem here is, if you just multiply by negative 1 to the 2, you've changed the whole entire problem. So I have negative 5s minus 2t equals negative 6, and then I'm going to rewrite the other one. So that's 9s plus 2t equals 22. So once you have the signs opposite, you get to add, you get to combine, linear combination, the two equations. So RC, negative 5s plus 9s is?
4s.
Negative 2t plus 2t is?
0.
And then negative 6 plus 22 is?
16.
So you solve for the remaining variable. 20 minus 6 or 22 minus 6? Are you on a different problem? 14. Okay, Jordan, what do I still need to do?
Substitute the 4 in with s.
Yeah, so which one do you want to do that in?
9s
Oh, that was 4. I thought it said 45. I was so confused.
S's are confusing. That's like when people use like zeros, or even like t's can be confusing sometimes because they can look like addition signs. I do that too. Usually with s's, I'll do like something like this.
I do a dollar sign.
Like put these on the s's so it makes it look a little bit more like an s. Oh, I'm very comfortable right now.
It is hot. Sure you are. You're just saying that.
So t is negative 7. Okay, this is not x and y. How would I write up this ordered pair? Yes. Alphabetical order. So 4, negative 7 is correct, Emma. S comes before t in the alphabet. If you need to sing the alphabet in your head, just do so. You don't need to sing it out loud.
That's Spanish.
Questions on that one? All right. So, if you have a system that contains terms that do not cancel out, even if you multiply one of them by negative 1, you need to determine by what number you can multiply maybe one or both of the equations by in order to make them cancel. So, you'll notice in front of the A, the coefficients in front of the A are 3 and 5, and in front of B is 4 and 2. Do you see that? Neither of those, if you multiply by negative, will get it to go away. But we can multiply by a number to get them to look the same. Is it easy to change 3 to 5 or 5 to 3?
Yes, ma'am.
With a whole number?
No.
No. Is it easy to change, with a whole number, is it easy to change the smaller number? So I'll just look at the smaller number, 2 to 4.
Yes.
So what would we multiply that by? Josh?
I was thinking about.
And why did you say negative 2 and not positive 2?
Because it would be 4 plus 4.
So if you just multiplied by a positive 2, like Josh said, this would make it a positive 4, and when you add it together, it wouldn't cancel out. It would give you an 8. So he chose to multiply by a negative because that would give us 4 minus 4, which would get that to cancel out.
Oh, what's up, man?
So Jayla, now that the B's are opposites, we can add it together. So what's 3A plus a negative 10A? 4B plus a negative 4B. 6 plus 8 is? Oh, Carter. Goodness gracious. Yeah. So we get A equals negative 2.
Whoa.
So Cassie, what do I still need to do?
Plug in into another equation.
Which one do you want to do? What did you say, sorry?
The top one.
Miss Brady, I have a question.
1 second. Side conversations. Stop.
Justin, I find that offensive.
So, Connor, what is my ordered pair?
-2, 3.
Alphabetical order. What's your question, Connor?
This one, what if they both cancel?
We'll talk about that.
That one doesn't cancel. Never mind.
Please tell me this number, like number example 4
Go on.
Every single of them cancels.
Oh my gosh, we're going to get to that one in just a second.
Is it all real numbers?
It depends. So if you cannot make terms cancel by multiplying just one of the equations, you may need to multiply both of the equations. So 6 can't multiply easily to get 8,
No, it's challenge.
and 3 can't multiply easily to make 4. Do you guys all see that?
Yes.
So we're going to have to multiply both equations to get the same number. So Connor, what are you thinking?
Well,
You want to make these 12?
yeah.
So what would you multiply 4 by to make it 12?
-3.
So you're making the negative on the top here.
That's okay.
That is completely fine. So that makes this a negative 12. So you need this one down here to be a positive 12.
Yeah.
What would you multiply that one by?
I feel good about that. Thanks. Don't give me your pity.
One needs to be positive and one needs to be negative in order for those p's to cancel out.
Didn't you multiply that negative 3/4?
What?
I did the same thing.
Yeah, but who likes trash?
Okay, let's try to stick with whole numbers. I'm not saying that that's wrong, but let's try to stick with whole numbers. I mean, I'm not saying that it wouldn't. That's not my point.
Whoa. We got ourselves a stalemate here.
Okay, so we can add them together. Negative 24 plus 24 is?
0.
Negative 12 plus 12 is?
0.
Negative 30 plus negative 30 is?
Negative 60.
Does 0 equal negative 60?
No.
What do you write? So if it's a false statement, we write no solution, meaning that the lines are parallel, meaning they'll never cross, they'll never intersect. So if we are inspecting the graph, you won't see that crossing. If it's a true statement, if it is a true statement, you write infinitely many solutions. You cannot write all real because that implies every single ordered pair on a grid is on that line, which is not true at all.
Are we going more?
You need to understand that infinitely many means that if you're inspecting the graph, the lines lay on top of each other. Okay, we have a few word problems. Do we have questions so far?
Nope.
Okay, stop the side conversations. We worked on word problems yesterday, right? You guys got to work with somebody? You did some more last night if you actually attempted them, and I did one with you today. So let's see what we can do. I did one from the homework today. So let's see what we can do with these ones. So let's try. Every time somebody talks, I'm not talking over them, I'm just going to stop. So if I teach all the way up till 12:05 or 12:06 when that bell rings for lunch, that is your problem. And you can talk to the people in this class that caused that problem. Do you understand me? Tickets to Six Flags cost $47 for an adult and $37 for a child. A few families went to Six Flags together. there were a total of 13 people, and they spent a total of $531. How many adults were in the group, and how many children were in the group? Define my variables, Jordan, coward. Define the variables.
The variables are like the thingies, right? X and Y.
X and Y, A and B, I don't really care what you call them.
Just give me a minute. So the X is right, like tickets or something, right?
Well, it's more than just the tickets.
Also tickets. How many tickets?
We know the cost of the tickets. It's $37 for a child and $47 for an adult. Why don't you read the questions at the end?
I heard the question.
Read the questions again. What is it asking you to find?
40 children were. How many adults were in the group?
And?
How many children?
So what are X and Y?
How many children and adults?
Thank you. So it's the number of children
Oh, so X is children.
and the number of adults. I would have used A and C because it makes it easier to know what I'm talking about later. Okay. So we have to keep like units, like pieces together. So it says 45 for an adult, 37 for a children, and those are all dealing with money. So I'm also going to highlight the 531 in purple because those are all the same unit.
Can I borrow a
I can find one second. And then there are a total of 13 people that went. So that is our other one.
Thanks.
Okay, so let's start with the total of 13 people. How would you write an equation that means, Colin, a total of 13 people?
Alright, you would just use X plus Y equals 13. Yeah, come on.
So the number of children plus the number of adults is 13. It's basically what that's saying. It's a group of people. It's like if you're going with another family or something. My family itself has 6 people in it, because I have 3 other siblings and both my parents. So like,
And my family, we have like 14 cousins.
right. I mean, if you're going with a family, that's really not that many.
No, I'm not saying that. I'm saying how much it costs.
Oh yeah, Six Flags is expensive though.
Yeah.
All right. How could we write the equation dealing with the money? RC, what would the equation be for dealing with the money? So what is it going to be equal to? Okay, so look at the other monetary amounts. It says 47 for an adult and 37 for a child. So it's $37 per however many children tickets we buy, plus 47 times however many adult tickets are bought, for a total of 531. So now we can use elimination. How could I use elimination here? So think about this. Before you realize this, when you get your homework tonight, you have to use elimination on it, because I just taught you elimination. Don't be using substitution. Do you understand me? If you start doing stuff that's a substitution, I'm giving you a 0. On the quiz, on Friday, you have a quiz, and one of the problems is by graphing, one is by substitution, and one is by elimination, and then there's also a word problem on there. But if you do the substitution one by elimination, it's a 0. I'm asking you to do specific methods so I can see that you can do them. Does that make sense? Do we all get that? Okay, Justin. Okay, that's not going to help me, though. There you go. What's 13 times negative 37?
6 times 11, negative.
Wait, what did you say?
37 times 13.
37 times what?
13.
481.
So now we can add those together. So I get 10y equals 50. So y equals 5.
Still got the right answer.
Well, no, duh. Why wouldn't I?
Now what do I have to do to figure out the number of children, Connor?
Substitute the Y for 5.
So since it's a word problem, we write our final answer as a sentence. So we will say 5 adults and 8 children went to Six Flags. One more example, and then you guys will get a chance to work.
Can I put 8 childs?
No, that's not a word.
It is. If you
The plural of child is children.
child
No.
Children.
I like geese.
No, moose is already plural.
Mooses. Gooses.
Mises.
Mices. Mices. Thesis.
Should be me.
It's like little
You're
geese.
gonna have no color, goose color.
I have so much.
Hey,
I have so
be able to
much
work.
spaghetti.
Okay, so a bookstore sells books and magazines just open. I feel like we've done this one. We're good to go then. Do you want your homework?
Yes.